Welcome to our project explanation. My name is Jintish. I am the team leader of the project focused on the ship detection in remote sensing images. Today I am here to share with you the details and progress of our project. Firstly, I would like to introduce my team members, Umar Farag, Bhuvan Rudraju, and our guide for this project, Pik Abhilash. I would like to thank him for his immense contribution in the project. Abstract. Our project revolves around the crucial task of shape detection in remote sensing images. You might wonder why this topic is significant. Well, shape detection plays a vital role in various fields, including maritime surveillance, environmental monitoring, and security. Being able to accurately detect ships from remote sensing images can greatly enhance maritime safety and enable different resource management. Yeah, let's see the existing work. The models mainly contain only detection of ships on SAR and remote sensing images. The models use the RCNN, DNN, YOLO V3, and YOLO V5. In the recent few decades, sophisticated ship classification methods emerged in response to improvement in spatial resolution of the optical remote sensing imaging. Therefore, ship identification and classification methods are introduced together in the following section. Proposed work. In order to improve accuracy, a convolutional network can be employed the backbone. We use CNN as a backbone for our project motivation and scope. This drives global trade but causes negative impacts on maritime environment and raises concern over traffic surveillance. So we are doing this project against illegal fishers to capture them and illegal ships in restriction areas. Introduction. The sea span moved two-thirds of that about the main covered about the seas which are in huge number and the ships are illegal in transportation. The major objectives of remote sensing images are traffic surveillance to detect illegal fishers. We use the CNN technique. It mainly consists of 5 layers to classify the image, and the models used pandas, numpy, matplotlib, scikit-learn, CSV. The literature surveys of our project, we have literally surveyed for 10 papers, through which we observed that all yield a less accuracy and uses a old algorithm which is very outdated. UML diagram, system architecture, use case diagram to the conversation between a user and a server. Use case diagram, activity diagram, step of activation activities taken in our project. Classes, user, server, detect, classify are the main classes with hyperlinks. Deployment diagram, let us have a quick implementation. These are some of images which are taken from the dataset to as a sample. Let's see the execution. From zip file, we are importing the files and extracting using the required packages, uploading the images, turning the JSON information into NumPy array, and then assign it to as our X and Y values. Then we are reshaping the data. As we know, the images are not in the very good shape, and every image should will not be in the same shape size. So we are cropping that. We can call it as a reshaping the size. Using this, we are reshaping the size of X and Y values and giving them a classes of ship and not a ship, which is majorly outcomes of our project. Exploring the images. Uh, Quick look at the ships images which are not ships and ship which were previously known from the dataset. We are plotting some of them using matplotlib, creating the train test and validation set. X-shaped, Y-shaped, X-train for training, X test for testing, Y-train, Y-test, and validation data, creating the validation data. X-train ship and printing the shapes of the models, setting up a baseline model and adding layers after each and every approaches. We have used the sequential model. It mainly consists of these layers. Flatten layer, the image indicating that the input consists of an image with dimensions 80 by 80 pixels and three channels. RGB flatten layer, the first layer which is used to transform the 3D input into 1D vector. This layer does not have any parameter. Dense layer with 200 units, both using ReLU activation function. Output layer, this model has denser with two units representing the number of classes, which are two, and we are using the optimizer Adam and loss categorical and Ross entropy for the images which are not of ships. Then training the model with the epochs 20, and then knowing our accuracy, how much correctly it is predicting. Adding more approaches and changing the activation functions result in the best accuracy. Here we have 50 approaches. With that, we have improved a little bit of accuracy, and we are changing the activation function to the softmax, and then making it train and test on that, and knowing the accuracy, and then plotting the images. These are the CSV files, CSV outcomes, then plotting it. These are the final plottings. CF5 is not a ship. It is a ship, so it detected with the high pixel intensity of the ships. So these two. Then we have added a CNN layer to achieve the high accuracy. We have achieved 98% of accuracy throughout this. Yeah, these are the final results of the accuracy and valid plotting accuracy and loss. Let's come to this. These are the snippets of our code, model construction, converting data from JSON to NumPy format, data reshaping, finding ANN, results, different models to opt in the best model, CNN model, plotting the histogram of an image, results. Yeah. Conclusion, with this CNN, we are able to get a good percentage, 98, which is the highest for this dataset. This process can be further enhanced by classifying the ships into various types. We can also use the dataset containing the surface of the sea taken by the satellites, and then detect and classify the image requirements. We have done in Google Lab, and these are the requirements of the Python and Python libraries. Let's come to the group members. I'm Jintish, the team leader of this project, Umar Farooq and Bhuvan Rudraraju. I would like to thank them for their immense support for me in this project. And I would like to thank our guide sir, PK Abhilash sir, for his immense contribution and always motivating us to do the project in a better way. Thank you, sir. Thanks.